So it turns out that even though Boyle's law, Charles' law, Gay-Lussac's law have different formulas, the basic premise for calculating all of them is the same. You're going to be given four variables, four things that could potentially change in the course of, some observation. But three of them, you're going to be told what they are. And one unknown to solve for. So here again, P1, V1 means the pressure times the volume before the first time we look, and P2, V2 means the pressure and the volume the second time we look, before and after. Okay? So let's say that P1 is 2 atmospheres of pressure, and let's say that V1 is 4 liters of volume, all right? Notice I'm actually deliberately writing this stuff out, and I'm going to say that P2 is unknown. I don't know what it is later, but I know that the size has decreased to 2 liters. Now, our general rule with Boyle's law, again, if the pressure goes up, then the volume must go down. So the question is, by how much? So to answer that question rigorously, we're going to write the variables in. So P1 is 2 atmospheres, so I write 2 atmospheres in parentheses. V1 is 4 liters, so I write 4 liters next to it. We should understand that that still implies multiplication. On the opposite side, P2 is unknown, so I just write P2, but V2 is given, it's 2 liters, so I put it inside parentheses. So now I have an equation I can solve, and what I want to solve for, of course, is P2. That's my unknown, so I want to get rid of that 2 liters. How do I get rid of it? I divide this side of the equation by 2 liters. That'll do it, because anything divided by anything is just 1. However, ladies and gentlemen, this is an equation. It must be equal, so whatever I do to one side, I must do to the other. Okay, now we're ready to solve. Of course, 2 liters cancels completely, so this is just P2 over here. Less obviously, the liters over here will cancel. And so this will become 2 atmosphere times 4, which is 8, divided by 2. And so my answer is 4 atmospheres. Now, actually, if you understand this, you didn't have to do that reaction, because you would have said, oh, 2 times 4 is 8. If that's 2, that has to be 4. You could have just kind of seen that with your mind's eye. But a lot of times you'll have numbers and it won't be obvious how the changes are. It won't be nice, even numbers like that, okay? So most of the time, your move is to write out your variables. Write out the 3 knowns, but figure out which one is unknown, and then plug them into the formula. And then use cancellation to isolate the variable that's unknown by dividing or multiplying both sides by the same variable. Okay, now I'm going to change laws now, okay? But if you're copying down this problem, it might be a good idea for you on a piece of paper, if you haven't done so already, to copy this whole setup. The formula for Charles' law is not based upon multiplication, but rather a ratio, division. We're going to have V1 divided by T1 equals V2 divided by T2. But the procedure for solving it is still the same. You're given in a problem 4 variables, 3 known and 1 unknown. Okay? So let's say our volume beforehand for some, say, balloon is 2 liters. And let's say that the temperature beforehand is 30 degrees Celsius. We'll use Celsius the first time. And let's say that the volume afterwards is unknown, but our thermometer tells us that the temperature in the room is quite a bit higher. And so the balloon must be at that same temperature after a while. Okay, so how do we solve it? Well, we've got 3 unknowns. We want to solve for V2. We're going to plug our variable in. So I've got 2 liters, V1, divided by 30 degrees Celsius, T1. And that's going to equal an unknown V2 divided by 45 degrees Celsius, which is the T2. Now what I want to do is I want to get rid of everything next to V2 or underneath V2. So in this case, the way I'll do it is I'll multiply the top here by 45 degrees Celsius. But again, since this is an equation, whatever I do to one side, I must do to the other. So I'll put 45 degrees Celsius over here. The 45 degrees Celsius will completely cancel on the right side. On the left-hand side, I can only get rid of the degrees Celsius. Okay, so 45 times 2 is 90. 90 divided by 30 is 3. 3. And so my answer is 3 for the volume. 3 watt, it's got to be 3 liters because that's the unit that wasn't canceled. Pretty straightforward. However, what if instead of solving for V2, which is on the top, what if we were solving for a temperature, T1 or T2? If that's the case, we're going to need a slightly different technique. Again, I'm going to give you about 30 seconds to copy down this problem on your piece of paper, and then I'm going to do a different Charles' law problem for temperature. Okay, so this time, I'm actually going to keep the first two variables, but we're going to solve for a different we're going to solve for a different thing here. I'm going to say that that my V2 is known. I'm going to say it's 6 liters, and I'm going to say that T2 is unknown. Now, for some of you right now, the answer will probably appear obvious because you'll understand that as V goes up, T must go up the same amount, and you might be able to do it in your head because I'm using nice round numbers. But most of the time, the numbers won't be nice round numbers, and so how do we handle this? Okay, well, one is we can at the end, we would flip it. The other way is to flip everything in advance. I'm not sure which way is easier. If you flip it in advance, you're really thinking clearly. If you remember to flip it in advance, it actually kind of saves a step. So what do I mean by flip it? Well, I mean that instead of V1 on top of T1, it would be vice versa. So we would put T1 on the top and V1 on the bottom. And then T2 is unknown. And V2 6 liters is on the bottom. And so to solve it at this point, we would multiply both sides by 6 liters. That completely cancels out. We get rid of the liters here. 6 times 30 is 180 divided by 2 gives us 90 degrees Celsius. So you can do it that way. Or if you don't remember to do it that way, well, then this is what happens. You would have 2 liters here, 30 degrees Celsius, 6 liters on the top, then you'd have T2 on the bottom. And if you go ahead and try to solve it right now just like this, well, you can, but you're not actually solving for T2, you're solving for the inverse, 1 over T2. So you have to watch out for that. But let's just say that this is the approach you take. If that's the case, we still multiply by 6 liters. We just do that on the bottom. All right, so the 6 liters would cancel out, which means it's just 1 on top. And here the liters would cancel out, and you would get 2 divided by 180. But what you'd have to do is you'd have to remember, wait a minute, this is the inverse of T2. And at this point, you'd have to remember to flip it. And so then this would be 180 divided by 2, and then you'd end up with the same result, 90 degrees Celsius. Now, I think flipping it at the beginning is neater, less steps. but many students have a hard time remembering to flip it at the beginning because they just want to follow the same formula all the time. It makes it easier for them to learn the formula if you're only doing it one way. So it's hard sometimes. So if you get at the end and you get a number that's obviously upside down, you can flip it. Now, if you can't flip it in your mind's eye, you could also do this trick. Okay, you could say 2 divided by 180 on your calculator, and you get this number. Well, that's probably not right because it should be a bigger number, right? Because if V goes up, T should go up. Charles' law isn't opposites. It isn't an inverse law. It's direct and linear. If one goes up, the other goes up. If one goes down, the other goes down. So if you get a number that's a lot less, then you know that's not the right number. You have the inverse of the number. Well, if you've already gone ahead and done the calculation, there's a little key on your calculator that says 1 over the x. So you just press that number, 1 over the x, and lo and behold, there's the same result, 90 degrees Celsius. So you can flip it at the beginning, you can do the math and flip it at the end, or you can just do the math and at the end press the 1 over the x key. Any of those results will work when you're solving for t. Now, that was actually the hard part. I'm going to leave that up for another 30 seconds so you can process that, and then we'll do one for Gay-Lussac, which turns out it has the same form as Charles' law and thus isn't that much different. So Gay-Lussac's law has the same basic structure as Charles' law in that we're going to divide something by temperature. Only instead of volume, V1, it's going to be a pressure, P1. Instead of volume, V2, it's going to be a pressure, P2. Okay, so that means I still need to do my setups, write out my variables. Still need to do that. Find my 3 knowns and my 1 unknown. Okay, so for this particular problem, I'm going to say that we have a sealed container and that it's at a pressure of 100 kilopascals. And we're going to say further that the temperature is 240 Kelvin. Okay, now we want to know the pressure later. It's unknown, but we don't know it, but we know what the temperature in the environment is at a later date. It's 360 Kelvin. Okay, so there are the variables. Now we're going to solve for our unknown pressure, P2. And so we have 100 kilopascals over 240 Kelvin equals an unknown P2 divided by 360 Kelvin. We're going to multiply both sides by 360 Kelvin. These completely cancel, so now this is just P2. 360 times 100 is 36,000 divided by 240. A calculator comes in handy here. 360 times 100 again is 36,000. Then we divide that by 240, and we get a pressure of 150 kilopascals. Now, needless to say, but I'm going to say it anyway, if you're asked to solve for T instead of pressure, T2 is on the bottom. So you have to remember to either flip the whole thing at the beginning, or after you do the calculation, you have to flip it and solve it manually, or you can just do it you can do it and solve it without it being flipped. But at the end, you take your answer and press the 1 over the x key on the calculator. Any of those 3 methods will work.